One more example. So again, in this case, we have a function that is defined piecewise. Okay, x squared for x less than 1, 2x minus 1 for x bigger or equal than 1. And we want to find if the function is differentiable for x equals 1. Why 1? Well, it's the point where the two pieces are glued together, right? So that's the only one that is special. Other than that, it looks like x squared and 2x minus 1 should be fine. I leave that for you to check. Okay, so you do check that f is differentiable for a different than 1. Okay, so that's a side task. Now, how does this function look? Let's plot it. There we go. So x squared is just the parabola, right? Whoops. So there we go. Let's put things, there we go. So this is x squared. And then we need the other part that is 2x minus 1. So it should be something like this. There we go. And it will touch somewhere here. So this is 1. Okay. All right. So then the function f of x that we are looking at is given by these two pieces. There we go. Continues here. And then once it arrives this point, it just continues straight following the tangent line. Okay, well, I said it's tangent, but we don't know that yet. So this is the mysterious point where we want to know what happens. All right, so let's get to work. To check the differentiability, the only way is to check the definition, the limit, okay? So for that, we need to check the lateral limit. So let's do first from the right, f of x minus f of a, which is equal to 1. Okay, a equals 1, divided by x minus 1. All right, so this is the limit as x tends to 1 from the right. Let's create some space here. There we go. And then we have f of x, which is 2x minus 1, because we are on the right of 1. Okay, we are approaching from this side, so it's 2x minus 1. And then minus f of 1. F of 1, so we check here x less than 1 strict, x bigger or equal than 1. So this is the formula we use for x equals 1. So when x equals 1, this is 2 minus 1, that makes 1. So this is 2 times 1 minus 1 divided by x minus 1. Okay, so let's see what happens here. So this is the limit as x tends to 1 from the right of 2x minus 1, that's 2x minus 2 divided by x minus 1. So the derivative is, we simplify, right? Because this is 2 times x minus 1. So the limit is 2. Okay. But then again, because the function is linear on the right of x equal 1, we already know that the slope of a linear function is the coefficient of x. So 2x, then the slope has to be 2. So far, so good. Now let's check from the other side. This is the tricky point, right? Fx minus f of 1 divided by x minus 1. So this is the limit, x tends to 1 from the left. Now from the left, the function is x squared, right? So x squared minus f of 1. Remember, x equal 1, the formula is 2x minus 1, so this is minus 2 times 1 minus 1 divided by x minus 1. So the numerator is x squared minus 1 divided by x minus 1. And here, remember the trick, this is x plus 1, x minus 1, the product. And we can simplify. And we have the limit as x tends to 1, okay, of x plus 1. And this is equal to 2. Oh, so they match. Okay. So because the lateral limits match, the function is differentiable at a equal 1. Okay, and then we write that the derivative at 1 is 2.